In this video, we want to evaluate the integral of 1 plus 1 over x squared all over x squared minus 1 plus 1 over x squared. Now we could simplify or rewrite the integral by multiplying the numerator and denominator by x squared. We get an x squared plus 1 in the numerator, x to the fourth minus x squared plus 1. Has the look of a rational expression here. You might consider partial fractions. Probably the easiest way, even though it's not obvious, would be to use a U-substitution. You may be given a hint to use this formula. The integral of du over a squared plus u squared. If you can write something in this format, that's always going to equal to 1 over a tangent inverse of u over a, or instead of tangent inverse, you can use arctangent. And this is the way we're going to go here. The fact that this problem is given in this format suggests that that's what you want to do. Now notice, if I had an x minus 1 over x in the denominator, because normally for the u substitution, you're going to let u equal to whatever something, or in some cases, you'll let u equal to the entire denominator, or you could let u equal to, say, the exponent of some expression, or say a factor in the numerator, or if you're dealing with trig functions, you could let u equal to one of the trig functions involved. That'll make it easier. So notice, if I take the derivative of this, the derivative of x is 1, and the derivative of 1 over x, well, this would be x to the negative 1. So if I take the derivative, minus 1 times that, minus there would be a plus, subtract 1 would give me x to the negative 2, which is 1 over x squared. But we don't have that in the denominator. We have this. You start thinking, what can you do? Well, I'm going to do this. I'm going to make this a minus 2. That's legal if I put a plus 1 over here, because minus 2 and 1 will still give me a minus 1 there, which is the same thing. And then, if you look at this part right here, that's the same thing as x minus 1 over x, quantity squared, plus 1. Check it out. Two terms here, you square it, so it's going to be x squared, which is right there, and then it's double that product, so x times minus 1 over x gives me a minus 1. You double it, you get the minus 2, and then you square this, and you get the 1 over x squared. So this three terms give me a perfect square, and then I got the plus 1. Same thing, those are the same. And all I did here is add a negative 1 and a plus 1. So they would cancel. Minus 1 plus 1 cancels. I still get what I started off with, which is a minus 1. So now look what happens here then. If I let u equal to x minus 1 over x, not the entire denominator, just that portion right there in the parentheses squared. If I find du here, derivative of x is 1. And then, like I said, derivative of minus 1 over x squared, minus 1 over x, take the derivative of that, and I'll write it this way so you can see it. So it's negative 1 times a minus, that gives me a plus. Then I subtract 1 from the minus 1, gives me a negative 2. So x to the negative 2 can be written as 1 over x squared, like this. And then I got the dx. So my objective then, using the U-substitution, is to convert this given integral into one involving the variable u. So this could be done by 1 plus 1 over x squared dx. That's this part right here. That's going to be your du. So this is du. And that's over. What do I have in the denominator? I have x minus 1 over x quantity squared. But remember, this is your u. So this will be u squared plus 1. So I said that the formula that we looked at basically said if you had anything in the form du over a squared plus u squared. Now this could be just a plain x. They used to u because sometimes you need to transform the integral using a u substitution. But you get anything that looks like this, and this is going to equal to 1 over a, and then arctangent of u over a. In the formula, this of course would be a squared here, and of course this is going to be u. 1 squared is 1, so basically this is telling me that a is equal to 1. So according to the formula, this should equal to 1 over a. In our case, it's 1 over 1 because a is 1, so this will be 1. That stays. And then it's going to be tangent inverse or arctangent. I'll use arctangent here. So it's arctangent of u over a. But remember, we're going to go back to the original variable. So u is x minus 1 over x. And that's going to be over 1. So if I divide that by 1, this would just be x minus 1 over x. And then you have your constant of integration. Now, I'm not saying there's not another way to do it, but you can see that this one works out pretty nicely if you can set it up accordingly. And like I said, they could give you a hint. They said, okay, use this formula here. And you say, okay, that looks like a setup involving u. And this is a standard formula that most instructors will expect you to know. This can be derived, and I did it in one video that I did, by a trig substitution. But anyway, here's the solution. Thanks for watching. We'll see you next time.